Alright, this video is just to report my progress with trying to figure out exactly what was damaged whenever this thing slipped and the top reversing bar hit the doorway of the garage. Well, I managed to pull it out without much complications. Just pulled the cotter pins and then took out the hex heads that were holding the support brackets in place. So what I've done is, lighting's hard here, let's see, I'm not going to get good lighting on it, but I managed to line the reversing gear shaft up with a straight edge. It should be, here, let's see if I can convince it to look there. So it's lined up with the square, but if we look at the end down here, the end right here, this is overhanging the ruler. So between here and here, this shaft is bent. Now, in addition to that, we also see that the handle took a big hit. That's the least of my worries, and I'm sort of thankful because it absorbed most of the energy of that impact. But the complication is here, because what ends up happening is this lever acts on this reversing bar via these arms. And whenever I have that bend in it, it introduces a twist to this and slides the coupling arms out of alignment with the valve. So my first attempt, I'm not sure what my first attempt is going to be. I'm going to think about it before I do anything hasty. But I'm wondering if it's possible that I can straighten out this shaft enough to remove the binding. Alright, now taking a different look at it, I've got the handle standing straight up and the shaft aligned with the edge of the straight edge. At this point, I want to say that I see a curve in this area here. Now, if I look straight down on it, let's see if I can get the focus in the right place. How about right there? So, if I look along the shaft, I can see that it is aligned with, again, get it to focus, with the ruler. So, this way it looks good. But if I look at it from this way, I see a curve in it. So again, how do I solve that? I'll think about it. Alright, to take a closer look and really figure out where my problem is, I broke out a small granite block and a pair of 1, 2, 3 blocks. The shaft is resting, focus here, on the back 1, 2, 3 block, and the forward 1, 2, 3 block is sitting in front of the shaft. It's there for reference. But if we look along the edge of that, we can see just how much that shaft has been bent down. I guess my next job is to make a measurement. Alright, so breaking out the gauges and trying to take some measurements. It looks like I've got about 0.03 inches of deflection between there and where the bracket was mounted. That's actually looking at about 0.05. Let's see, what am I going to say? Let's say it's 0.45 at that point. Focus there. Now, I'm not going to be able to get that gauge down to the end here without a whole lot of work. But it looks like I've got even more deflection between that point and the end. Now, I had considered invoking this gauge here, but based on that, it looks like the amount of deflection that I've got in that shaft exceeds the range of this gauge. So, looks like I might be stuck. And just going to have to guess at it at this point. Okay, so after taking some measurements, I determined that there is a 0.12 inches of deflection of this end of the shaft from straight. And I marked here where the transition occurs. Now, I think I might be able to highlight, yeah, here we go. I can see here, this is where we've got wear because the shaft was binding inside the mount. So it's actually bent past that mount. Now, the easiest part to take care of, and the least critical, is where I'm going to start, is with the handle. Because the handle got bent as well. And I realize it's not going to be a total fix, but I'm hoping that if I squeeze it in the soft jaws, that I can straighten that handle out a bit. So I'm going to go ahead and give that a shot. Alright, the vise did straighten out the handle a good bit. It didn't do the whole straightening, but I didn't expect it to, and at this point I'm wondering if I need to fuss with that anymore. The big issue is still that bend in the shaft. And to that end, I am now considering putting the shaft in these V-blocks. I'm going to make soft jaw liners for these. But if I can stand it up like so, I might be able to use another V-block on top where, and then put the whole assembly in the press over there. I might be able to gently put the shaft close enough to straight to be able to work. The main thing I'm concerned about is getting that binding out, and it's involved with, because the shaft is bent along this section, this is now cockeyed when engaging with what I think is called the Johnson bar. So I'm going to put together some copper liners for these V-blocks and eye that up to see if it makes any sense. Alright, so after fashioning some soft jaw liners for my V-blocks. This is the basic idea that I hope will get me into place. I'll just put this to the side for here for now. But I want to set it up in the, I know it's shaky because I'm using one hand and trying to get this shot, is set it up in the press where I'm pushing on this portion of this block to try to get that shaft straightened out. Now, I'm not going to do it now because I don't want to rush things. Besides, I have to set up the press. But the intent is that this shaft will be positioned like so, and hopefully I'll be able to take that bend out of that shaft. It only turns whenever I'm changing from forward to reverse, so it's not like there's a whole lot of concern over minor binding, but the big concern is this lever here and getting it to operate these arms here without inducing a tweak to this mechanism where it's twisted. So I'm gonna sleep on this. Probably won't get to it until Monday evening after I finish digging in another place. But if I haven't changed my mind, that's what I'm gonna try to do. And if worse comes to worse, I can always work on refashioning this shaft from new stock. It looks like it's, aside from the length, it's a matter of drilling 3 of the right size holes in the right orientation. Huh. Easier said than done, huh? So that's it. We'll see what happens. Well, as I had said, I was planning to try to put this shaft in the shop press, but after thinking about it overnight, it occurred to me that I had less control over it rotating while I was trying to nudge it back into straight. So I decided I was going to try using clamps on the milling machine to see if I can bump that shaft back up into straight. So what I've put together is a way of using a bridge here to pull up on the edge of the shaft while the rest of the shaft is being held down in V-blocks. Now, initially, the distance between putting it in these V-blocks and putting it on the milling machine also let me adjust the angle so that I had the bend in the shaft straight down so I could pull against it. Now, initially, whenever I was checking how far the shaft was bent downward, I was getting numbers which were on the order of, can I read this? About 1.27. And now, with it bridged up the way it is, I'm getting about 1.34. So I pulled it up a bit, but I suspect as soon as I release pressure on it, it's going to spring back. But I wanted to go at this slowly So I'm stopping at this point because it's pretty close to being straight. But I want to see how much spring back there's going to be after I release these nuts and remove the tension pulling up on the end of the shaft. I'm going to check that out now. Alright, I had to increase the length of these upright bolts, but I managed to bend the end of this shaft so that when measured from the top of here to here, I get, let's just double check it while I'm here, I get wait a second, let's do that right. I'm getting, come on, focus. Put it down. I'm getting 1.315. And if I measure the height of the shaft here, I get 1.355. So I'm off by 0.04. 0.04, yeah, 0.04. So it's at least worth taking out of the fixture and putting it back into the steam engine and seeing if it made a positive difference. Alright, so I fitted the shaft back onto the steam engine, and I am very pleased with the way it's operating now. I had a lot of binding because this crank was cockeyed on the shaft. There's still a little bit, but like I said, I estimated it to be about 0.025 of deflection. And the thing I'm really happy about is whenever I'm in one forward direction, that I've got this rod right underneath the valve, and then whenever I'm in the other direction, this rod is right underneath the valve. With that crank being out of position, this was not lining up. So I'm really happy with the way it's going. So I'm calling that a success. I've got another project I'm going to look into, but I'm not going to worry about that now. I'm happy and I'm done. Take care.